Hey everybody, welcome back. Hope you've had a great weekend. Tried to get this one out Friday, but a bunch of stuff came up and I couldn't, so we're trying to crack into it on a Monday. Mondays are normally tricky post-weekend, but I'm trying to smash this. Might be over today or tomorrow. See how we go. All right. Firstly, we can welcome the new microphone. So yeah, the old one seemed to have had its time in the sun, and then it went a bit funny. Fingers crossed this one will be sounding better. Let me know how the new one's going. Alrighty, rather than get into the summary of the Hambini document, which was my initial plan, I decided I'm going to get through the fun deep dive on the hybrid ceramic versus steel bearings, which is really what started the whole issue between Hambini and myself a long time ago. And it makes more sense to do it in this order, as it's going to sort of form part of the summary. Otherwise, I'd probably end up doing two summaries. So I'm switching the order up a bit, and I think you'll find today a really interesting video as we go through the information for and against sort of hybrid ceramic versus steel, and most especially Hambini's testing of bearings, which is, let's just say, very, very interesting indeed. Firstly, thank you to everyone who bore with me across the last 5 episodes. Yes, I know that was a lot, and certainly some feedback from some that, perhaps too much. But the plan was always I was going to deal with that document point by point, counter every piece of utter BS, engineering embarrassment, and misleading and dishonest sort of crap that was put in there, as well as there was just obviously so much bizarre stuff as well, which he just thinks he didn't even know what he was talking about. So it was fun to, I guess, explain through every point, and I know I can be sometimes a bit overly thorough. However, that does leave, I think, no stone unturned as to who is correct on any particular point. And I will be doing a full summary, and I would work really hard to try to get that summary concise for me, but at least it is on record. And yeah, it just took what it took. So if you, to a degree, if you are concerned about the length, you can redirect that to the person who gave me so much to need to correct. Because if that document was, let's just say, a whole lot better and contained some actual accuracy and honesty, then it would have been a lot faster for me to get through. Alrighty, first up, sorry again about the length on this one, but it is a bit of a deep dive. I don't, make any videos like this lightly where I'm going to be outlining some deep concerns about what somebody is potentially doing. So I want to step out in a thorough and logical order what substantiates those concerns, so that then you have the best information to decide whether I'm correct or Hambini is correct. So I promise along the way you will learn some cool stuff about bearings and which bearings may be a great choice for you. You will also learn a whole bunch about testing in this space, and because it is, as always with cycling, testing specifically for cycling is just a whole bunch of fun. So I think there'll be a fun journey here to follow, but let me know if I'm incorrect at the end and you're annoyed with me for wasting 55 minutes of your time. But otherwise, you can also just zoom straight to about the 50-minute mark, check out the summary, and then if there's anything specific that you want to, get the deeper information on a point or what's behind a point in that summary, then you can always just duck back. Alrighty, let's go. Alrighty, so it was about, I think, 7 years ago, Hambini kind of launched himself onto the scene with a hybrid ceramic or a ceramic versus steel bearing video. And the nuts and bolts of that was that hybrid ceramic bearings are pretty much an industry-wide con. The harder ceramic balls will wear the comparatively softer steel races quite quickly and become higher friction than quality steel, according to his testing, after just 1,000 kilometers. And therefore, what is the point of paying all that extra money for hybrid ceramic bearings when they are not going to last as long and be higher friction than steel anyway, in pretty short order? So we need to have a look at that, because that does go against a lot of other information that we have, both from real world cycling as well as from industry with regards to hybrid ceramic bearings. And so we'll be having, I guess, a bit of a deep dive look at Hambini's data and the testing that sits behind that data, and asking some, what you'll see are very interesting questions around that. Right, and I think if you have any level of objectivity in your noodle at all, you'll see not too far into this video that it is bonkers that he has been able to get away with keeping his testing that sits behind this data secret and continuing to do so. And to say that it's hypocritical in the extreme to have not released in full the testing protocols, I cannot fathom how you could deny that if you're a Hambini fan. All right, so as we go through the video, so we're going to get into the data and questions around the testing in just a moment. But as we go through today, I want you to consider these questions, I guess, running in your noodle as we go. Is it possible the guy that has pitched himself as an expert in bearings and is apparently a highly qualified aerospace engineer, if he is incorrect with regards to hybrid ceramic bearings versus steel, I want you to ponder how that could possibly be the case. And if there's no technical or knowledge, expertise reason that sits behind how he could be incorrect, what other reasons could there be? Is there perhaps a commercial incentive for this particular pitch of steel being superior? As a bit of a spoiler, let me tell you that all the information that I can find from industry, as well as we have now decades of real-world use of hybrid ceramic bearings in cycling, the only information that I can find in the world that has hybrid ceramic being inferior to steel is Hambini's testing and data, for which the testing and protocol that sits behind that data is secret. So that's just a really interesting, I guess, thing to know as we delve into it. All right, so this today is not a discussion on whether or not hybrid ceramic bearings are worth the extra cost for you and your cycling over quality steel. As this can be a separate discussion on another day. For many, many cyclists, quality steel is absolutely the way to go and all you ever need. However, the information that's been presented by Hambini, that hybrid ceramic bearings are quickly higher friction and obviously also higher wear than quality steel, that is what we're going to have a look at, and whether or not that information is correct. And if it's not correct, how would Hambini be incorrect on such information, being an engineer and a bearing expert? Alrighty, let's go. Let's have a look at Hambini's video from I think 7 years ago, and the very interesting data and questions we have around the testing that sits behind that data.
Mechanics, stresses, contact stresses, all that out the way. Let's consider some hard data with some graphs and numbers. This first graph is the one that everyone really wants to see. So I took some 6806 bearings, spun them up to 90 RPM, and then calculated the power that was absorbed.
Alrighty, I know that was a short section, but we already have some big questions. So just take note of the wording there. So he took some 6806 bearings, which are fairly standard bottom bracket size bearings. He says he spun them up to 90 RPM, so that is giving us, I guess, an indication that this is a motor spinning up these bearings. We don't know the load. And then he has calculated the power absorbed. One would think also, I guess, used or consumed. So how has this been done? Right, so just take note of the scales here. So we have the Enduro ceramic at 0.13 of a watt loss. NTN non-contact seal 0.14. Ceramic speed 0.15. SKF, 0.16. And then the next one 0.17. So basically the top five are separated each by 0.01 of a watt. So that's an extremely precise level of accuracy for power consumption, or the power that those bearings have absorbed, consumed, used, whatever you want to call it, to be spun up to 90 RPM at load unknown. Because the testing is secret and we don't know, but I guess referring back to Friction Facts, when they did testing for bottom brackets, they used, Jason Smith used extremely expensive and extremely precise torque sensors. Now, a torque sensor is we'll call it a measured result. That is a direct measurement of the loss. Hambini states that he has calculated the result, or the power absorbed. Typically, that would be used if one is, looking at how much power is being drawn from a power supply from a volts times amps perspective. So how many volts and how many amps, you multiply those two together, you get watts. So you would need, not saying that it can't be done, it can be done, but there are a bunch of traps that can be fallen into when trying to use power consumption via that method. And you obviously need an extremely accurate power supply. To be 0.01 accuracy, I think we are entitled to know how this has been calculated, what equipment has been used, so the motor and the power supply, so that we can get some indication as to how accurate we think that is. And going by Hambini's own critiques, I think we would need a certificate of calibration for the power supply to be that accurate, that we're talking 0.01 of a watt difference. Was he using something like this from AliExpress for $178, or was he using something like this, which is around $2,000? And in its own manual, which probably isn't available for the one from AliExpress, we can see the voltage and current rating accuracies there of basically plus 0.01% and 0.02%, which is going to be the minimum accuracy level needed for calculating wattages to 0.01 of a watt. So what equipment did he use? What was the test protocol? What was the test load? Basically everything we need to know if those figures are accurate or not 0.01 of a watt accurate, we do not know. Alright, so please keep all that in mind as we go to the next part of his data, because this all becomes very important. So whilst we can certainly call it plausible, feasible that he has conducted this initial test to that claimed accuracy by using the right equipment, the next data that he presents is showing that the Enduro's hybrid ceramic bearing has become higher friction due to wear of the steel raceways from the harder ceramic balls, and therefore higher friction than the quality steel over a 10,000 kilometer cycling simulation test. So how on earth has this 10,000 kilometers of cycling been simulated? Because a bearing being spun to 90 RPM by a motor, if that is well within the bearing's load rating, which one would have to assume that it is, considering those very low loss numbers, how on earth has this wear and high friction occurred in a bearing so quickly? Because a bearing spun by a motor, they truck on for an enormously long lifespan, and one of the key benefits of hybrid ceramic bearings, as you'll see from industry, is typically 4 or 5 times greater wear lifespan as opposed to quality steel. How has he induced a higher wear situation in his test? Because 10,000 kilometers of cycling, if we equate that across to a bearing being spun by a motor, so call that the equivalent of, say, a bearing lifespan in a motor, that is not going to be troubled at all. If we have a quick play with some figures, back of the napkin math, just to put his 10,000 kilometers cycling test into some perspective. So let's assume that his 90 cadence or 90 RPM test equated to an average cycling speed of 30 kilometers an hour, which is a fairly stock standard speed we'd expect for a cycling test. That works out to basically the 10,000 kilometers of cycling would be a total of 1,798,200 bearing revolutions. If we equate that number of bearing revolutions to what a bearing in, say, an electric motor would be doing, if it's, say, a fan motor doing 1,000 RPM, that's 60,000 revolutions per hour. If we divide the 1,798,200 revolutions total from the 10,000 kilometer cycling test by 60,000, then that would give that bearing only a 30 hours of service life before it has become worn and high friction. And that is frankly bonkers. Typically bearings in motors will have a service life of thousands of hours. And in the case of, I guess the bearings in my test machine, so my oldest one, which has ceramic bearings in the bottom bracket, that is over 200,000 kilometers of life so far for those bearings, and they are still silky smooth. So how has he managed to induce wear and get this result that we'll see in a moment from just 10,000 kilometers of a cycling simulation test? Because it simply cannot be done if these bearings are just spun smoothly by an electric motor at 90 RPM. The only way to do that would be to load the absolute bejesus out of these bearings. And we do not get an indication of that from the fact that initially the bearings are only losing, like the top 5 are under 0.2 of a watt loss. If they were very highly loaded, those losses would be greater than that. None of it makes sense. So let's have a bit of a look at that data. One final spoiler as we get to the Hambini data. When we look at industry, the big benefits touted by, or for going the path of hybrid ceramic bearings, the reason why industry spends the big bucks to put hybrid ceramic bearings in some of their machines and motors, is the much greater service life as well as the efficiency. But looking at whilst we're at this part of the thing, the 4-5 times greater bearing longevity is the key point that we want to focus on. Because, what on earth would be the point for anybody to make hybrid ceramic bearings if the harder ceramic balls are just going to very quickly wear the comparatively softer steel races? If we then extrapolate that math across to, say, a 10,000 RPM motor that's driving a machine in industry, we've then got an effective bearing service life of 3 hours before the bearing is worn. Like, that's just absolutely nuts. So those bearing service lives in industry machines, the big benefit for them is their much extended lifespan versus steel. So obviously that does not match up to Hambini conducting a test whereby the bearings are spun by a motor, because if the test was conducted that way, then the hybrid ceramic bearings would have around a 4 to 5 times greater lifespan and not be showing a poor result versus quality steel. So, it cannot have been conducted that way. You cannot do a 10,000 kilometer cycling test by spinning it via a motor. How has he done it? So the test protocol for this next data is extremely important, and it is, again, beyond bonkers, beyond hypocritical, considering his criticisms of other companies, to have this testing secret, the protocol secret.
But that doesn't tell the whole picture. If we go to this next slide, which is the bearing life, this is effectively the bedding in period of the bearing, and the red and the blue are NTN and SKF respectively. The red line is an NTN bearing which has a steel cage. The SKF bearing has a TN9 cage. Both, the power absorbed doesn't really increase much over kilometers, whereas the power absorbed by the Enduro bearing increases significantly. And that is due to the hard ceramic balls basically wearing the raceway away.
Right, so still using the terminology of power absorbed. So to me, it's saying to me that he's conducted this test the same way as the initial loss test, which would obviously make sense because it's continuing on from that 0.13 watts loss and zooming up. And surpassing the steel bearing losses after just 1,000 kilometers of cycling. I cannot fathom how you could induce that in a hybrid ceramic bearing being driven by a motor at 90 RPM in that short an amount of time. Let's have a look at what some industry has to say with regards to hybrid ceramic bearings. And I'm initially going to industry as opposed to cycling, because obviously the cycling retailers or manufacturers of ceramic bearings are going to obviously claim that they are superior because they're marketing ceramic bearings. When we look at industry that at the end of the day, are selling a huge amount of bearings for all applications and bearings of every single type imaginable, they are going to be neutral with regards to telling you what the benefits of steel are and the benefits of hybrid ceramic. They have no incentive really to tell you that hybrid ceramic bearings are superior for an application if they also sell high quality steel, which the major manufacturers obviously do. So in essence, they are neutral parties in what they are putting forwards, and that's why I'm going to use information from industry first for this next part. With SKF, since that's one of Hambini's favoured bearing suppliers, skip the preamble, we don't need that. We don't need to know about electrical erosion or operating speeds really. Reduce friction by half, we'll be circling back to that a little bit. Focusing more on longevity at the moment, but just take note here that the characteristics of silicon nitride, which is for the ball bearings, to help reduce friction by a substantial 50% through optimized machine design. Extend life despite contaminants. Silicon nitride rolling elements mitigate the impact of external particle contamination, helping to preserve bearing integrity and performance for a longer service life. Ease lubrication challenges. SKF hybrid ceramic bearings can withstand poor lubrication conditions, such as very thin oil films or non-standard lubricants like refrigerants and cryogenic gases. Extend grease life. Can extend grease service life by up to 8 times, potentially reducing maintenance costs for relubrication or changing greased for life bearings. They've got a bit of a chart there, so don't worry about the electrical erosion part, but grease service life up to 8 times longer service life, and bearing service life in a contaminated environment or harsh lubrication conditions. It's got there 4 times longer. Quick chat on that. Okay, that can be relevant for us in cycling. Again, the bearings in cycling can be exposed to a lot more harsh conditions than in a lot of machines, which typically are fairly sealed. And so, as we ride, our seal lips on those bearings will wear, and that can make ingress by water and the crap that water brings in an occurrence. And so, operating conditions, simply can be quite not optimal for bearings in cycling. And the hybrid ceramic bearings simply hold up to such circumstances much, much better. So you may have heard on some podcasts or cycling channels where mechanics, especially in, say, cyclocross, have said, look, they used to run steel and quality steel just due to cost of the top hybrid ceramic bearings, but they get a bit tired of changing the bottom brackets every week or every second week. And since going to something like ceramic speed, they've now got the last 2 seasons out of that bottom bracket and everything is going great. So especially if you do in your own cycling, ride a lot in wet conditions, most especially wet off-road conditions, the advantages of hybrid ceramic can be much more pertinent to yourself than somebody who's riding only in dry road conditions. Let's have a look at a bit of a case study by FAG, which is part of the Schaeffler Group, another favoured company by Hambini. On they did a deep test on hybrid ceramic versus steel in spreader rolls, which are part of a paper machine, so installed in the wet section and the drying section. So I won't obviously spend the time to read all this. You can just pause it and read all that if you like. And same with this page here. The nuts and bolts are that so the service life can be 3 times as long as that achieved with a steel bearing. And the conclusions, more or less, so the lubricant is subjected, this is for hybrid ceramic, subjected to less stress thanks to the small mass and favourable contact geometry of ceramic balls. Low friction special rolling bearing greases with a good oil retaining capability which have a long life are used. As the outer ring of the bearing rotates, there is a risk of the base oil being... that's okay, we don't need to know too much about that. Tribological properties of ceramic balls, they're less negatively affected by lubricating film breakdowns and starved lubrication conditions than steel balls, as the elements in rolling contact are significantly less susceptible to adhesive wear. The smaller mass of the ceramic balls results in slighter gravitational forces to the ball cage assembly. In application, we don't need to worry about electrical current or the modulus of elasticity too much. Higher cost effectiveness. The system cost is determined not only by the bearing acquisition cost and the cost of the mating components. Another significant factor are the operating costs, repair and downtime costs, a significantly reduced power consumption. So again, we're going to be referring back to these efficiency side of things soon. And maintenance cost contribute to a low operating cost. The hybrid ball bearings considerably extend the operating time of the spreader rolls. The bearings have to be replaced less frequently, which extends maintenance intervals and so on. So, now I could go on and on. There's a lot of information out there to be found on hybrid ceramic versus steel bearings in industry. If you wish to dive deeper, go and dive deeper. Now, one of the main comebacks that Hambini is probably going to be shouting around this time is that, hybrid ceramics, though, are not suitable for applications which involve vibration and shock impacts, of which we could potentially put cycling into that application. So, aside from what we've gone through industry there, where let's assume that those applications are all nice and smooth, what do we have that could potentially offset Hambini's insinuation that hybrid ceramics are not suitable for cycling? Okay, part one is Hambini's information himself. Let me actually pull something back up on screen. Back to Hambini's manifesto of embarrassment in his document around ceramic bearings, he states, in 2004, Schaeffler, through their bearing brands, developed a martensitic hardened steel that would later carry the trade name Chronotec. This material was exclusively used by Campagnolo for 2 years, from 2008, in their Super Record bottom brackets. Schaeffler conducted extensive testing of several million cycles to validate the product's performance in comparison to their regular offering. They were a supplier to Hope at this time. This segment of Schaeffler's business would evolve into Schaeffler's Velo Solutions. Despite the well-documented marketing material produced by Schaeffler, Kerridon has repeatedly claimed these tests never took place, which that is not true. Even though it's widely known that this type of bearing has specific applications, namely inner ring interference only, due to its poor shock performance. Campagnolo has generally only used the bearing in inner race interference applications. So that whole section there is honestly pretty bizarre. The only way I can really interpret that, and so I have covered this a bit in, I think it's episodes 2 on the rebuttal of his document there, is he saying that only Schaeffler managed to crack the code on how to make steel races sufficiently hardened to run hybrid ceramic balls? Because obviously that is not true, and all the major industry bearing makers, as well as all the major suppliers in cycling that are making hybrid ceramic bearings, such as Ceramic Speed and Enduro, Kogel and Seabear, and you name it, will lay claim to the fact that, hey, guess what? Our steel races are also awesomely hard and perfectly capable of running hybrid ceramic balls and give you that awesome extended lifespan that you can expect. So typically with hybrid ceramic bearings, you will get a very high quality steel race. It can be that it will be a more hardened and higher quality steel race that you will get in cheaper steel bearings. So this insinuation that he sort of put across there about Schaeffler and their special martensitic hardened steel races, it doesn't make any sense. Martensitic steel was patented in, I think, around 1912, and lots of industries and manufacturers have been making martensitic hardened steel for various applications for a very long time. You may have heard of, case hardened or face hardened teeth on, gear cogs and just you name it. It's out there. So that's pretty bonkers. Another part is obviously talking about that section of Schaeffler that is supplying these special martensitic hardened steel race bearings that are hybrid ceramic to Campagnolo, and that they're only using them basically pressing on via the inner race onto the Campagnolo Ultra Torque cranks. How has he missed this, for instance? By chance ever seen on a lot of Campagnolo's wheels, they're hubs with Colt bearings, which are their ceramic bearings. So they are ceramic balls running on a hardened steel cup and cone. Fulcrum also have the same under the USB or ultra smooth bearing moniker in the Fulcrum wheel set. So a lot of the higher end ones for Fulcrum will have the exact same hubs and bearings because Fulcrum's a sister part of Campy. So leading directly on from Hambini's own information, we have clear cases of hybrid ceramic bearings being used extremely successfully in cycling. No matter which way you cut the cookie, it doesn't make any sense. So obviously, Schaeffler are not the only bearing manufacturer in the world to solve hardened steel races. It's like, oh my God. He has seemingly and unbelievably for a guy who's an expert on bearings, missed the fact that they're using them in cycling hubs. So we already have information directly from him about a, successful program from one bearing manufacturer to introduce hybrid ceramic bearings into cycling quite some time ago. I will put to you that Schaeffler are not the only ones to do so. What is he doing with that paragraph? So what else do we have, overall? So at the end of the day, this is going to come back to just mostly anecdotal, but what we have is well over a decade of extremely successful use of hybrid ceramic bearings in cycling in both hubs as well as bottom brackets as well as pulleys, where the service life of the high-end hybrid ceramics are typically vastly greater than what you will get from quality steel. So again, absolutely nothing wrong with going quality steel, and in a lot of setups they will have a great service life. However, in a lot of other applications, and especially the more harsher applications such as off-road and wet off-road, the hybrid ceramics just, it's not even a competition. From my own personal experience, I've been now riding mountain bike and cyclocross and gravel for quite some time, and especially through winter, I am mostly off-road versus on-road. And it's such a peace of mind that if I do a really harsh full mudder wet ride and I take my chain off to sort that out quickly for a re-wax, and I spin my crank and it is just like, holy Batman, there's a whole bunch of crap in my bottom bracket bearings, I can reset those very easily and they're back to silk smooth. And sometimes I don't have time to reset my bottom bracket. I can pop the chain back on and just keep going. And then when I can get to it, I can flush clean my bottom bracket bearings and re-grease them, and they go back to silky smooth because they are high quality hybrid ceramic bearings. I used to run steel and they just do not come back. Once you run them with a whole bunch of crap in there really for any amount of time, even that ride, they just don't come back. You clean them perfectly, you can take them out and ultrasonically clean them perfectly, re-grease them, and they are never smooth again. They have been damaged. They simply cannot hold up to the same level of abuse that hybrid ceramic bearings can. And my story is repeated world over by countless cyclists. All right, and it's important to obviously note that we shouldn't just focus on bottom brackets. Hybrid ceramic bearings have been used very successfully for well over a decade in our wheel hubs, free hub and pulleys. Especially with regards to wheel hubs, they are experiencing much greater levels of vibration and shock as opposed to, say, your bottom bracket, and they're also going to be a much lower load rating because they're smaller bearings. So any issues with hybrid ceramic bearing use in cycling, it's going to show up in our wheel hubs pretty quickly. And if, as we know, we're getting tens of thousands of beautiful, silky, smooth kilometers and amazing service life from our hybrid ceramic bearings in our wheel hubs, there is not an issue with hybrid ceramic bearings in cycling. So the one who's stating that hybrid ceramics are not suitable for use in cycling, if he's taking the due to shock and vibration line, then he needs to provide some substantiation of that, because we have well over a decade of successful use in this actual application that he has to combat this actual real world knowledge with something, and he's given nothing. The only data we have that I can find that says that hybrid ceramic bearings are not suitable for cycling comes from Hambini, based on a 10,000 kilometer cycling test for which the protocol is secret. Does that pass muster or pass scrutiny with you? Like if Hambini had a twin brother and Hambini was having a look at this video by Hambini, and I would imagine the original Hambini would be in for quite the reaming to present this information based on a secret test, and it's information that goes against everything we know about hybrid ceramics from industry and from well over a decade of successful use in this actual use case of cycling. Like, it's bullshit. He's put forward about why the testing is secret shortly, but let's just cover off a last little bit of rather interesting data.
If we come on to this next slide and talk about it, I went to NTN, SKF, NSK, and also Schaeffler, which is on the next slide, about how they distribute friction losses in a bearing at low speed. So 90 RPM sinusoidal loading means that the loading occurs as it would in a pedal stroke. So it's not completely across one pedal revolution. It's, you know, for a quarter of a revolution, and then you get a dead spot, and then another quarter, and so on. But if you look at the data, it's fairly consistent across the three manufacturers. The majority of the friction, or the power absorbed, comes from the seal. So NTN's at 60, SKF's at 54, and NSK's at 58. Then the grease is around at 30%, and the 10 to 16% is in rolling friction. Schaeffler, which is INA FAG bearings, gave me some more detailed information, and they said the seal was 60%, the grease was 28%, and then they split the rolling friction down, and they said cage friction was 7%, ball deformation was 3%, and raceway deformation was 2%. So cage friction is the only element of friction inside a bearing where it's not a rolling movement, it is a sliding movement. So it's quite plausible that that's where most of the friction comes from. That's 7%. The ball, deforming inside the cage is only 3%. So if you go from steel to ceramic, and the results show there's not much difference, and that's the reason why, because there's only 3% of the total deformation.
All right, so in essence what he's saying there is that, look, there's no point going to ceramic balls, because even if they are smoother and therefore more efficient, the only area that you can save some efficiency is out of that little 3% slice of the chart. So let's say they're twice as efficient, then you've got a 1.5% figure in there instead of 3%. It's still bugger all improvement overall for the bearing efficiency and speed. But there's a couple of issues with that data. So number one, what bearings were they? Because you cannot attribute those percentages just to bearings. Those loss percentage breakdowns are going to be very different for a bearing where it has a heavy contact double lip seal packed full of heavy duty grease. The loss factors for the seal and the grease in such a bearing would be very, very high, and I imagine that is the type of bearing that data comes from. Compare that to, for instance, say a bearing where we have a no contact seal and a very low fill of a very fast grease, then those loss factor percentages will be much lower. All of a sudden, how smooth and fast the bearing is, so the rolling friction there, is going to be a much higher percentage, and depending again on the loads and the speeds, those percentages will all change. So the main part there is that you just simply can't say that is the percentage breakdowns for bearings, or the bearings that we're talking about, because they are going to be quite different. The other part is, so you saw at the start, it was talking about sinusoidal loading, and he was talking about obviously with pedaling action. So is he saying that NSK, Schaeffler, NTN have gone out and conducted via some sort of pedaling rig sinusoidal loading that mimics cycling to get these loss numbers? Because I can tell you that, and I'm not saying this testing doesn't exist, but in the world of bearings, cycling makes up an extremely tiny percentage of any of those major industry bearing suppliers' bearing sales. Bearings are in everything and everywhere at every scale. Cycling is bugger all. The odds that they would go and have a cycling testing rig to assess the percentages of loss coming from the sinusoidal loading of cycling, I think that's low. And for not just, I guess, say perhaps one industry player to have done it, but multiple, I don't know. Let's have a look at what a sort of a cycling pedaling rig might look like. Credit to Pandapodium for that video. I saw that that came up on my Instagram feed a little while ago. Now, yeah, so one of those rigs is quite something, and that's just showing the pedaling. I'm not entirely sure what they're doing with that. However, with such a setup, measuring losses extremely accurately at the same time, boy, oh boy, that is a challenge. Again, just for those major players to go through the effort of trying to do that for cycling, I certainly have some doubts. So if we cast our minds back to the, percentage efficiency gains that we saw from industry there of sort of 40% and 50%. Now, again, we don't know the speeds and the loads and so on. However, the difference with those efficiency gain claims is that we now have a ceramic ball instead of a steel ball. So I think it's likely that we're talking about more than a 3% slice of the pie that could be up for grabs in our cycling application bearings as well. He has passed off that data as being a cycling sinusoidal loading testing by those manufacturers. So I'm not saying that testing hasn't taken place, but without actually seeing the testing, I am calling BS that these major manufacturers have conducted such specifically for cycling. I think this data has come from some other type of sinusoidal loading testing, because for sure there's lots of machine and industry applications where sinusoidal loading is going through bearings. I think he's taken data from whatever X industry situation that was and just ascribed that as, hey, this is their test for cycling. And I'm calling BS on that until he proves me that I am incorrect, which obviously he should be able to do. Alrighty, so as we've covered, really the only data and information that exists that hybrid ceramic bearings won't give you some great advantages in cycling application, just like it does in pretty much every other application they're used for, is coming from Hambini, and it's based on testing that to this day remains secret. Now, he has given reasons as to why this testing remains secret, so we'll run through those, and you tell me if these reasons in any way pass scrutiny, and how come he's not applying his own standards to himself that he applies to other companies around their testing and information. Okay, so reason number one is he accuses me of being unwilling to pay for the standards testing. However, this is not any standards test that he has conducted to assess these bearings in a cycling bottom bracket. Had he named a particular test standard that I could purchase to understand the test protocol, then I simply would have done so, obviously. So the fact that it is not a standards test and he's using as a reason that I was unwilling to pay for a standards test to access the requisite information is utter BS. Reason number two is that I needed to go and read a tribological book first. And again, that is just such an utter stupid thing to have to say to someone before they would release their testing protocol. Let me show you friction facts. Testing on bottom brackets from probably about a decade ago. Here's the friction facts bottom bracket test, and this was done quite some time ago, but I'll whiz through it. Back in the day you did need to pay for this, but since he has disbanded friction facts, I believe now all this is open. So he explains in brief some of the testing, and that his test does in fact induce some lateral loading as well. He explains how that lateral loading is introduced, and then after all the testing reports, we come down to he will give basically a fairly detailed overview on exactly how the test protocol was conducted. So we can read the information as he explains the test protocol and how he's doing the loading calculations and understand that we do not need to have read an engineering book on tribology to simply know how he has tested the bottom bracket bearings. This is just quite simply exactly what Hambini should be releasing and should have released 7 years ago without even needing to be asked, quite obviously. So, I mean, just utter madness, and obviously, in my view, extremely dodgy to try to hide behind not releasing your test protocol. Hey, go and read a book on tribology instead, because that is not going to tell me how he's conducted the testing still in any way, even if that was done. Reason number 3 that he's put to me in email conversations is that he is not going to share his intellectual property. So he's protecting his own IP around that test. So for one, that obviously still reinforces the fact that it is not an industry standards test. It is his own test protocol that he has created, and he wishes to protect the IP around that. However, that falls apart to me on a couple of reasons. Number one, I am not aware, so I could be wrong, but I do not believe he is offering testing services as a commercial service for bottom bracket bearings. So he's not, I don't think, protecting a testing protocol from somebody else stealing his, what needs to be done in how to test bottom bracket bearings. Number 2 on that, even if he was doing commercial testing for manufacturers for bottom bracket bearings, it doesn't help them at all if the test protocol is secret, because if a manufacturer gets a result, let's say a manufacturer employs his testing, gets a poor result, how are they going to understand how they've done poorly in the test if they do not understand how their bearings have actually been tested? So, same as the friction facts testing was open when they were testing bicycle chain lubricants. My testing is fully open. Manufacturers need to understand the test so they can understand the results for the test, and where things, especially if the test result has not been great, where it may have fallen over in that test protocol. So what can they look to try to improve for the next round? And also, as we saw with friction facts, if we have a suitably qualified person who wished to enter, if they thought that they could somehow actually make money, because holy Batman, it is not easy to make money from testing, if they thought that they could offer a bearing testing service and make a viable commercial return on that, they will already be thinking and knowing how they're going to go about conducting this. I don't think there are people out there going, geez, I wish I could make the big bucks from testing cycling bottom bracket bearings. If only I knew how Hambini did his test, then I could go forth and do that. Like, on no level, in absolutely no angle, I don't think that you can look at this, does it pass any sort of scrutiny or logic that Hambini can keep this testing secret, most especially so in the face of it is providing data that goes against everything else out there in the world that we know with regards to hybrid ceramic bearing performance, and also their real-world use and performance in cycling. And obviously, in light of what he has done re-attacking other companies around their testing and data secrecy, or testing protocol secrecy, I should say, it is beyond hypocritical how Hambini acts towards others versus what Hambini does from his own side. Summarize all this, but you know me, we covered a bit of ground there, so even my summary is rather epic. Alright, so we do not know how he tested for outright efficiency, and we should. We especially do not know how he simulated 10,000 kilometers of cycling test, and we really need to know this. We do not know how he attained a higher friction increase due to the wear rate result for the Enduro hybrid ceramic bearing, which goes against the known increased wear life of hybrid ceramic bearings. The crap around Schaeffler, their martensitic steel races, their specific testing division that sold hybrid ceramic bearings for inner race interference fit applications only to Hope and Campagnolo, it is all nonsensical garbage written to fool the large and easily fooled part of his channel audience. It is also nuts he missed Campagnolo's cult bearing hubs, and to insinuate that other manufacturers haven't yet figured out how to make hardened steel bearing races. The data for the loss breakdown for a bearing showing balls to be only 3% of the loss simply cannot be attributed to bearings. Any more than testing rolling resistance tests, say by bicycle rolling resistance, and ascertaining for one tyre a breakdown for tread, casing and tube, could then be applied to all bicycle tyres. Quality ceramic bearings in industry applications offer significant wear life advantages over steel bearings. They extend the lifespan of the grease. They deal much better with contamination and harsh conditions. They deal much better with low lubrication levels, especially if that is accompanied with vibration. all factors that have cross benefits for cycling application. Real-world use in cycling for well over a decade has proven the above benefits carry over versus steel, most easily seen in the harsher cycling applications such as cyclocross or wet off-road cycling. Hambini's assertion that hybrid ceramic bearings are not suitable for cycling application due to the presence of vibration and shock, he has not quantified what level of vibration, so frequency and amplitude, and shock load versus the load rating of the bearing, that is experienced in cycling application versus the bearing's ratings, and demonstrate damage to the bearing from use in the application. Simply, this is a vague throwaway line. Where is Mr. Aerospace's engineer's precision? Why is he able to make such statements as fact that are completely unquantified by him, and yet he slays others for levels of impreciseness at a small fraction of this example? And again, we have over a decade of real-world use proving this throwaway assertion incorrect. The reasons Hambini has provided regarding keeping his testing protocol secret do not pass any basic test for honesty and integrity. There is no standards test that I or anyone else can purchase to obtain his testing protocol. This is level 1 that he is trying to use to hide behind not releasing. Neither I nor anyone else will need to read an engineering book on tribology to understand his test protocol. Just release it exactly the same as friction facts or zero friction cycling. This is a frankly ludicrous and embarrassing assertion to put to the world. Protecting his own intellectual property for the testing makes zero sense. What commercial BB bearing testing is he offering to the manufacturer? What would the manufacturer do with a test result when they do not understand how it was tested? And who is he protecting the IP from? The people who are waiting to go into the commercial BB bearing testing services? If only they knew how Hambini did it. It's ridiculous. Overall, when Hambini has testing results that go against all other knowledge on hybrid ceramic bearings, as well as their extremely successful real-world use, and now very widely adopted use for over a decade in cycling application, it is important to know how such a result was obtained. That he has and still is keeping this testing secret, I personally find extremely concerning. Note this secrecy also carries over to his aero testing, a video for another day that will be rather fascinating, and of course, extremely concerning. As nothing adds up on this on any level, I personally came to hold the concern that Hambini was simply being shrewd. The ceramic bearing upgrade aftermarket is extremely contested and crowded. Why step into that pond when you can instead convince people that the entire pond is an industry-wide con job? Buy quality steel instead, preferably from him, of course. I obviously wish to be incorrect in this concern 7 years ago, but try as I might, I could get nothing from Hambini to alleviate that concern. And it is a concern that has only deepened as we see how Hambini operates in the years since. Secrecy behind his testing and the data is the norm. Ask questions around this and you are attacked by Hambini, and yet he applies a completely different standard to other companies if their test protocols are not open. How do Hambini fans square that circle? The utter hypocrisy. Anyone with a working frontal lobe will see straight through all this, and only the no longer thinking sycophants can possibly defend such. I ran out of time, but I will cover in another video on bearing hints and tips why Hambini is also wrong, read the polyamide versus steel cages, but again, his information is simply easily proven incorrect. So you tell me, do you believe that Hambini is incorrect regarding hybrid ceramic bearings? If you believe he is correct, please tell me how, in the face of a mountain of industry information and well over a decade of proven use and superior outcomes in cycling. If you believe he is incorrect, how? How could an aerospace engineer and self-appointed bearing expert be wrong about something any one of us with an internet connection and or simply using these bearings arrive at the correct place rather quickly? If there is no way for him to be incorrect due to lack of knowledge, what other explanation is there around what he has pitched to the cycling world? Do you find it acceptable that his testing is secret and hidden behind the reasons covered, or should he be demanded to simply release the testing protocol in full, just like Friction Facts did, just like zero friction cycling? All right, that better do. Thank you for making it all the way through to here if you did. And yeah, I know it was very thorough again, deep dive, but I have whenever I have something where I've got serious concerns, I don't make any videos like this lightly, and so I don't want to be just throwing around trash that's unfounded. And I hope I've been able to structure the information and presentation in a way that gives this the full weight as to why I do hold the concerns that I do. And I really do hope that one day we see some better transparency and integrity from Hambini on this topic and oh so many others. All right, till the next one. And again, and for those that obviously I'll get some, no doubt, excellent comments of support. There'll also be, no doubt, some comments of those who are just obviously not got their sort of circuits working and are just full fanboy. And no matter what he does, he could probably set a box of kittens on fire on YouTube and he'd still have undying support from some people. If you're going to post something like ceramic bearings of snake oil or anything like that, like, what's the point? If you're going to make a comment, if you're going to have input, substantiate it. So if you just put a baseless fanboy comment on, it'll be treated obviously as such. If you wish to dispute any particular point, then dispute that point with, something to back it, if you can. All right, till the next one. Have a great, I don't know if I'll get back to another video on Friday, bit on, but yeah, if not, I'll try to get back to the sort of the normal scheduling with the video next Friday. Okay, till then.